This is Geometry, Notes section 16.2. This is radian angles. The concepts in this section are the same concepts that were in the previous section, 16.1, but instead of using degrees, we're going to use radians. Students have trouble with this most of the time because they are not very good with fractions. This is a good reason for us to study this so we can get practice with fractions. Radians. The radian measure of an angle in standard position is defined as the length of the corresponding arc of the unit circle. A unit circle is a circle whose center is at the origin and has a radius of 1. Here's what you need to know. This would be like if you heard nothing that I said for these entire notes, this is the most important thing. 1 revolution is 360 degrees, which you already knew, which is also equal to 2 pi radians. So that means if we go all the way around the circle, that's going to be the same as 2 pi radians. If we go halfway around, that should be half of 2 pi, which is pi. Halfway between 0 and pi would be half of pi, pi over 2. Halfway between pi over 2 and 0 would be a fourth of a pi over, or just a fourth of a pi, pi over 4. If you look at these, this is showing you the relationship between these degrees and these radian measures. So here's how I remember it. I know that pi is equal to 180, and 45 degrees is 1/4 of 180. Therefore, 45 degrees is pi over 4 because pi is the same as 180. This is something that you have to be able to derive on your own. If you were ever asked to label a circle whose center is at the origin and radius is 1, that's called a unit circle, measuring by pi over 6, which is the same as 30 degrees, and measuring by pi over 4, which is the same as 45 degrees. So let's check this out. Draw a circle with radius 1 whose center is at the origin. Label each angle around the circle counted by pi over 6 and pi over 4. So let me show you the easy way to do it, and then I will show you what has to happen after that because we always want our fractions reduced. When I say always, I mean most of the time. So let's say this is a unit circle. Radius is 1. Let's count by pi over 6. Now a lot of these angles I'm going to draw and I'm going to put their measurements off to the side because they're going to have to be reduced. So I'm going to divide each quadrant into 3 equal sections because pi over 6 is the same as 30 degrees. 30 plus 30 plus 30 is 90. Each quadrant is made up of 90 degrees. So here's how this works. At the beginning, counting by pi over 6, we have 0 pi's over 6. So I'm going to write that down, 0 pi over 6. Now you know that's 0, but work with me here. If that's 0 pi over 6, this first mark must be 1 pi over 6. And the second mark must be 2 pi over 6. This is going to get reduced. That's why I wrote it off to the side. So we got 0 pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. See, if you don't ever reduce your fractions, fractions aren't that difficult. The bottom number stays the same each time, and we increase the top number by 1 each time. Now, if we do reduce these fractions, which we want to, 0 pi over 6 is 0. 1 pi over 6 is fine. 2 pi over 6 reduces to pi over 3. You can divide top and bottom by 2. 3 pi over 6 reduces to pi over 2. You can divide the top and bottom by 3. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6 doesn't reduce. 6 pi over 6 reduces to pi. Let me just bring to your attention something else here. What if we counted by pi over 3's? We got 1 pi over 3. We got 2 pi over 3. We got 3 pi over 3. See how that works? Continuing, 7 pi over 6 doesn't reduce. 8 pi over 6, you can divide top and bottom by 2 and get 4 pi over 3. 9 pi over 6, you can divide the top and bottom by 3 and get 3 pi over 2. 10 pi over 6, you can divide both of those by 2 and get 5 pi over 3. Then you get back to the beginning, 12 pi over 6 reduces to 2 pi. That is counting by pi over 6, and that's something that you are expected to be able to do. What if we count by pi over 4's? Pi over 4 means 1/4 of pi, which means 180 divided by 4, that's 45. So each quadrant gets broken in half because 45 is half of 90. Now if we count by pi over 4's, at the beginning we got 0 pi over 4, and then we have 1 pi over 4, then we have 2 pi over 4. Notice that 2 pi over 4 reduces the pi over 2. We already have that there. Then we got 3 pi over 4. Then we got 4 pi over 4, which is already reduced. Then we have 5 pi over 4. Then we have 6 pi over 4, which reduces the 3 pi over 2. Then we have 7 pi over 4. Then we have 8 pi over 4, which reduces to 2 pi. Now you might be wondering, what is our infatuation with 30 degrees and 45 degrees? Our infatuation is special right triangles, 30, 60, 90, and 45, 45, 90. That is the key to all of this, and that will not go away. Expect a pop quiz tomorrow over this, where I ask you to draw a unit circle, counting by pi over 6 and pi over 4, and you draw all this and you reduce these fractions. Example A, draw an angle in standard position with the given measure and identify the quadrant in which the terminal side lies. This is what I would insist that you do for this. Since this denominator is a 6 and we got pi on the top, I would draw these quadrantal angles without reducing, making sure there's a 6 on the bottom. So for example, beginning we got 0 pi over 6. If we make a complete revolution, that's 2 pi. And if we're going to use a denominator of 6, that's the same as 12 pi over 6. Now, if here to here is 12 pi over 6, then halfway around must be halfway between 0 and 12. That's 6 pi over 6. Halfway between 0 and 6, that would be the positive y-axis. That's 3 pi over 6. Now, if you look at the pattern, our numerator, each quadrantal angle, it increases by 3. We get 0 plus 3 pi plus 6 pi. Plus 3 pi is 6 pi. 6 pi plus 3 pi is 9 pi over 6. Add 3 more to the top, you get 12 pi over 6. So this fits the pattern. 5 pi over 6 falls between which two fractions? Well, it falls between 3 pi over 6 and 6 pi over 6. Probably should use a different color. So in standard position, this is the angle that we are trying to draw. Number 2 is also using denominators of 6. And it's a negative angle, so we're going to go in the negative direction. So we got 0 pi over 6. Complete revolution is negative 12 pi over 6, because that's the same as negative 2 pi. Halfway around is negative 6 pi over 6. Going in the negative direction, halfway between 0 and negative 6 is negative 3 pi over 6. It's going to make this 9 pi over 6 negative. So we get 0, negative 3, negative 6, negative 9, 12. It's a consistent pattern. Negative 11 pi over 6 falls between negative 9 and negative 12. So the angle that we are drawing is going to be in quadrant 1, like so. Same concept as degrees, but we're just using radians. Example B, find the measure of each angle in radians. What makes this hard is the fractional part. From here to here is pi. And if I want to compare these easier, I want the same denominators. So instead of me saying pi, I'm going to say 3 pi over 3. So from 3 pi over 3 to get from here to here, this is the part we're not going to use, so we want to get rid of this part. So if we get rid of that part, that means we're left with 2 pi over 3. In other words, 3 pi over 3 minus 1 pi over 3 is 2 pi over 3. This is our answer. Number 2, going in the negative direction, so our answer is going to be negative. If I mark my quadrantal angles, this is 0 pi over 12. Halfway around is negative 12 pi over 12. Halfway between 0 and negative 12 is negative 6 pi over 12. So from here to here is negative 6 pi. Here's another pi. That makes the angle I'm trying to find negative 7 pi over 12. Number 3, it's a complete revolution plus a little more. So let's measure these quadrantal angles by something over 5. So we get 0 pi over 5. Complete revolution will be 10 pi over 5. Halfway around is 5 pi over 5. Halfway between 0 and 5 is 2.5. So our numerator goes from 0 to 2.5 to 5. We're adding 2.5 each time. So the negative y-axis is 7.5 pi over 5. And then add 2.5 more, we get back to the beginning. So that gets us to here. So if we add another 2.5 to the top, that's 12.5 pi over 5. Add another 2.5, we're going to get 15 pi over 5. And then we're getting super close. So the answer is definitely going to be bigger than 15 pi over 5. Now how much is this part right here? We've established that 90 degrees, using 5 as the denominator, is 2.5 pi over 5. So we use one of those pi over 5s there. That means we must have 1.5 pi over 5. It's not very visible. This little angle here I'm suggesting is 1.5 pi over 5. So in total, we got 10 pi over 5, 12.5 pi over 5, 15 pi over 5, plus 1.5 more. That's going to make this 16.5 pi over 5. That is that angle. Number 14, we're going in the negative direction, so answer is going to be negative. We made a complete revolution, so that's negative 12 pi over 6, which is the same as saying negative 2 pi. Halfway around is negative 6 pi over 6. If we start at the beginning, I guess I got ahead of myself. At the beginning, we get 0 pi over 6. Halfway around is negative 6 pi over 6. Halfway between 0 and negative 6 is negative 3 pi over 6. So that means the positive y-axis is negative 9 pi over 6. Then we got negative 12 pi over 6. Then we got negative 15 pi over 6. So to get all the way around to here, we're at negative 15 pi over 6. We go pi over 6 more. That's going to put us at negative 16 pi over 6, and that reduces to negative 8 pi over 3. Example C. Find one positive and one negative coterminal angle with each angle. Coterminal angles are complete revolutions apart. One revolution is equivalent to 2 pi radians. Something I forgot to mention, if you don't label an angle, it's assumed to be in radians. That's why it's super important when you have an angle that's in degrees, you use the degree symbol. Number 3, there's no symbol here, so we are to assume it's in radians. The pi doesn't make it in radians. The fact that there's no symbol makes this radians. So if I got 7 pi over 6 and I want to find a coterminal angle that's positive, I'm going to add a complete revolution to this. A complete revolution is 2 pi. 2 pi written as a fraction with 6 on the bottom is 12 pi over 6. That's going to give us 19 pi over 6. A negative coterminal angle, I'm going to subtract a revolution or a multiple of revolutions from this. If I subtract 2 pi, which is 12 pi over 6 from this, I'm going to get negative 5 pi over 6. Example D, find a coterminal angle between 0 and 2 pi. Well, if I take the angle I'm given, which is clearly negative, and add 1 revolution to this, so what makes radians difficult is this is still 2 pi, 8 pi over 6, 8 pi over 4. It just doesn't appear to be that way. Because when you add fractions, you need common denominators. If I add these together, I get 3 pi over 4. Is 3/4 between 0 and 2? Yes. Therefore, this is the angle that we are looking for. Example E, convert to radians in terms of pi. What is the one thing you're allowed to multiply by anytime you want, and it never changes the value of what you're multiplying by? That is 1. 1 can take many forms. As long as you are multiplying by a fraction in which the top and the bottom are equal, that means you're multiplying by 1. So if I take 135 degrees, I want to multiply this by a fraction that's equivalent to 1. Remember, 1 revolution is equivalent to 2 pi radians. Remember that 360 degrees is equal to 1 revolution. That means 360 degrees is the same as 2 pi. As a fraction, if I write 360 degrees over 2 pi radians, this fraction is 1 because the top and the bottom are equal to each other. If you divide something by itself, you get 1. If I wanted to make this with easier numbers, I could divide the top and bottom by 2. Half a revolution is 180 degrees. Half a revolution is pi radians. So I'm going to multiply 135 degrees by 1, and I want my degrees to cancel. So I'm going to put 180 degrees on the bottom and pi on the top. This fraction is 1 because the top and the bottom are equal to each other. You folks have done this before in science classes. I believe it's called dimensional analysis. Not with radians, but like if you had 15 feet and you wanted to convert that to yards, you would say, well, 1 yard is equivalent to 3 feet. Feet cancel. So this is going to give you 15 yards over 3, and that reduces to 5 yards. 15 feet is the same thing as 5 yards. This concept is the same. It's dimensional analysis. We're dividing the top and bottom by degrees so they cancel. So now we got 135 pi over 180. Can this be simplified? It can. You can divide the top and bottom by 45, and that's going to give us 3 pi over 4. 45 goes into 180 4 times. 45 goes into 135 3 times. This is our final answer. Number 2, negative 45 degrees. Put that as a fraction. I want degrees to cancel, so I'm going to put 180 degrees on the bottom. 180 degrees is equivalent to pi radians. If you don't write radians, you can use an abbreviation RAD for short. It's assumed to be in radians. So cross-canceling, degrees cancel. 45 goes into itself. 45 goes into negative 45, negative 1 time. 45 goes into 180 4 times. If you multiply across the top, you get negative pi over 4 radians. Convert to degrees. So it's not written, but it's implied that this is in radians. So I'm going to multiply this by a fraction so that my radians cancel. 180 degrees is equivalent to pi radians. So the radians cancel, the pi's cancel. Now I have 3 times 180, which is 540, and the only unit that is left is degrees. Number 2, I got negative 2 pi over 3. That's in radians. I want to get rid of the radians. I'm going to put pi on the bottom, 180 degrees on the top. Pi's cancel. 3 goes into 180, 60 degrees times. So I'm left with negative 120 degrees. Just want to draw attention to one last thing. I've said it once, but I'm going to say it again. 1 revolution is 360 degrees, is 2 pi radians. This is also equal to one other thing. The circumference of a circle, 2 pi times r units. This is the formula for circumference. This is important. Thank you very much.